For the last day of chapter 5, I put down the title day 1, but it's called Independent Events, and there will be only one day of section 5.6. The idea of independent events is really quite easy, and we've been basically doing it since the start of the chapter. It was only in the previous lesson, dependent events, where we strayed. So what I want to do is just verbally give you guys a couple of examples to show what the word independent means, and then we'll do just one example. It's one of my favorite examples ever, very simple to do, and it just shows it very nicely. So first of all, let's say you were going to do some kind of experiment or some kind of competition where you could say we have a die and we have a deck of cards, and then if you could roll a 5 and flip over a heart. Well, we didn't do it. Well, then you'd win a prize. Then you'd be looking at some kind of probability. Let's not worry about the calculation. Let's just look at it this way. When you roll the die and when you flip the card over, they are independent. What number this comes up with and then what this is, there's no way the die can affect the card. Even if I roll the die and it hits the card, well, so what? It doesn't affect what's going on. It is independent. Now, to show that maybe even better, we could take a look at when you have two cards with replacement. So let's say that I wanted to know what is the probability of, on a standard deck, of getting 2 clubs. Well, here's the thing. We could flip this card over and it's a club. Okay, great. Don't worry about that. Don't start running numbers. The idea is if I take that card, put it back in the deck, and then try to reshuffle and flip over, and then we just want to know, is that card a club? Well, the first one being a club has nothing to do with the second one. It does not affect it. It's not like the dependent event, where in the dependent event, when I flip this card over and I don't put it back in, well, then there's fewer cards in this deck. So what happened here, the next one depends on it. So that's the idea. An independent event is where the first thing, because you're replacing, doesn't have any impact on the second. Now, what would be one of my favorite ways to do that? It would be a question where you're driving home and you're just on the lookout for different cars. You love looking at cars. And in the PDF notes, it says the probability of seeing a Ford Mustang at some point as you are going home could be 3/5. There's a few of those cars out, especially now that it's summer. And then my very first car ever that I bought right out of university was called an Eagle Talon. They don't even make those anymore. I don't even think Eagle is a real car company anymore. So let's say that car, that red sports car that I bought, the probability of seeing one of those is only 1/10. Now, here's what we could do. We could do a number of calculations. What if we said on your trip home from school to your house, what is the probability of seeing both? Well, here's how you'd go. The probability of this event happening, it's 3/5 for the Ford, and it is 1/10 for the Talon. The word and means to multiply. That's always meant to multiply. The word or is when you add. So all we simply do is we multiply these fractions. 3 times 1 is 3, 5 times 10 is 50. Now we have our probability. The next question. What is the probability that on your way home you don't see either? Well, here is where we do the complement. It's the anything but. This is the probability of seeing a Ford, 3/5. What is the probability of not seeing a Ford Mustang? Well, it's the everything but. It'd be 2/5. This is the probability of seeing an Eagle Talon, 1/10. The complement, the probability of not seeing it, everything but, would be the remaining 9/10. Then we just do the same thing. You're not going to see the Mustang and you're not going to see the Talon. We would have a probability of 18/50. Now our grand finale is kind of a neat one. What is the probability you see only one? So again, university profs will somehow code it, the probability of this event. That's all the E stands for. And so here's how we start. If you see only one, let's start with, let's say you see yes to the Ford. Well, then you have a 3/5 chance. What about the no to the Talon? Because you're only seeing one. Well, it'd be the complement, the everything but, the 9/10. And then we could get a total probability of 27 over top of 50. But that's not the only thing. It could be the other way. It could be no to the Ford and yes to the Eagle Talon for a 2/50. And now watch. It could be this and that. It could be this and that, so we multiplied. But here's the thing. When we're doing the only one, you're going to see either the Ford or the Eagle Talon. Well, the or means to add. Our total probability, we would add them together to see a total of 29 out of 50. And that would be how we would end our entire chapter, introducing you guys to probability in a university level stats course.